Fucking broadcast, man. Anyway, didn't get very far. Um, Good morning again. Let's get going. With your submarine, subterranean, subsistence, subsisting suboptimally, the only way you're getting out of this cave anytime soon is by finding a path yourself. Not just a path, the best path. So they gotta find all of them. Fortunately, the sensors are still mostly working, so we built a rough map of the remaining caves. Your puzzle input. Okay, so that's a map. Or graphing edges. There's a list of how all the caves are connected. You start in the cave named Start, and your destination is in the cave named End. An entry like BD means that cave B is connected to cave D, and you can move between them, so it means it's both bidirectional. Your goal is to find the number of distinct paths that start at start, end at end, and don't visit small caves more than once. There are two types of caves: big caves, written in uppercase, and small caves, written in lowercase. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. So all paths you find should visit small caves at most once and big caves at any number of times. Given these rules, there are 10 paths. Oh boy. So this is like a breadth first search, I think, would be best here, but I don't know how big it's going to be. I'm thinking of a few ways to represent these paths, because we can collapse this into A starts, then you have B, a block that begins with B, and then you have inside you have a block that begins with B, and one that begins with C, and one, etc. Then you flatten it, you count the amounts of time you have N, and then you're done. Each line above this can correspond to a single path. The cave visited by the paths are Now this cave system case D is never visited by any paths. To do so, it would be feasible to visit twice. Yeah, so we build in a rule that does that. Slightly larger example. The 19 paths are as follows. How many paths to this cave systems are there that visit small caves at most once? Okay, but this is good. We have 3 examples. I like that. Because it means that I can build 3 examples and have more test cases. So this is, what, 10? 10. I suspect that we're not gonna get numbers for the rest for a part 2, but you know. It's even larger, almost 20 hands. There we go. So first, what we're gonna have to do is build a map. Fuck me, what's the best way to do this? I do not know what would be the best option in Erlang. Three, 252, 226, and you're 19. About C, and then we can try that later. Okay, so what we're gonna need is we're gonna need to make some kind of like two nodes or parse nodes, parse edges. This I feel is one of those days that is like instantly solved in a few of the path the like Python libraries, but unfortunately, this I think is going to be a long-ish day. Mostly because I'm going to need to write a particular breadth. I'm going to do depth first or breadth first search. I don't know. I think breadth first search might be a bit better, but I don't know. I think you can probably do some pre-optimization by cutting off loops where a... It shouldn't matter. The thing is, I need to think of an approach to take. The implementation won't matter. Both will be fine. But it's more what would work better for my bloody mind. Flip a coin. Wow. So what we need to do first is take a look at my input, which is just a dash. So we do starts, comma end equals So here's the thing, right? My idea would be to keep both nodes and just append it to it. So just have like a list of basically like this. So you'd have like starts and then everything that it links to. I mean, that's basically what you have to save. I guess in theory you can have some sort of structure that allows you to not to doubly save things, but I think this would be the best way. Thinking if it's an easy way to... Oh, there was some kind of way to easily create something, but I need to append to it if it exists. Oh, wasn't there a default though? Yeah, there was a maps get default. I just missed empty list. Yeah. Map equals maps dot map. No, it's full is what it's gonna be. Oh, no, I guess this is just, because we only have two, it's easier said than done just to do this. And this will be E, so this will be maps get s comma map comma empty lists. So this should append it to both E O. I hate this syntax so fucking much. It is atrocious. Thank you, Erlang. I love it. Alright, now we just need to have a fall through case. Empty list, map. Give me a map. Let's see what we get. Start CB. Oh, yeah. So A, let's go double check this so we're not insane. A goes to start CB, yeah. So basically what I want to do now is see if I can do some sort of pre-optimization here, because we know that no path will visit D, because it's a single line connected to only a small cave. So when two small caves are connected... Nah, because it could be a loop. No, there's no way you can make that optimization. I guess not. What you could do is literally check if the only other connection that it has is a small cave. That's all that I can think about. Which would in principle make it easier. Because it'll... The thing is, nah. I just need to build in a traveling case that says if we travel back to a cave that already had, yeah. Yeah, exactly right. The thing is, we're still going to navigate to B. So say we end up at B from, I don't know, start, whatever. And we have these options, right? I would then go to D. The only other option would be go back to B, and I would say I already have that in my lists. So we're done. We end this run, and we just carry on with the next permutation. The issue for me is, how do I keep track of to visit things? And I'm not entirely sure what's the best way to do that. I'm probably overthinking this quite a bit. Because we have a map, we already have a grapher, or a graph. We don't even need to do any weird, like, A-star pathfinding here. Okay. It's unused. Okay. Traverse. With our map. So what do I need? I need to also have a... we want to keep track of our, like, paths. Yeah. Paths. Some sort. Oh boy. Okay, where do we start? We start at start. I think that the way that I thought of was actually is going to be pretty okay. So what I basically want to have here at the end is something like this. So we have starts, and then the next position can be A, comma B. It's like we can grab the example here we want. So A, oh crumbs. Yeah, like A, comma B. And then no, like this, right? Yeah. B, comma, and then in here, another list of all the options. So in this case, it would be, you know, A can go to B to C and to N. So it'd have B, comma, C, C, comma, and then you'd have end as an atom. Which I don't think we can actually do. No, like this, I think. And this will be a node. So we'd have to get something like nodes. Well, that would just be, you know, the keys here. And then you can have B go to A and N, so something like that, but end would just be a node name, so this would just be the same as this, you know. But building this up, the thing is, how do I prevent recursion from breaking this? Because you can go start, end, start, end, start, end, infinitely. So how do I detect and break up that loop? Because we should be able to do that. Oh, wait, start as a small cave, right? Yeah. And start and end are small. But what if you have two large caves right next to each other? Is that ever happening? No. There are never large caves next to each other. Yeah. Okay, that's nice of them. Or is that in here the case? Okay, so we don't even have to think about that edge case. That's nice of them. Okay, so that makes this a lot easier. So it means we'd never have to take care of those edge cases, which means that this approach can probably work. Because what we can do at the end is just flatten it. And what we can do is to keep going is to see we take any path that doesn't end with end. So this will work. So how do I build this, right? So say we start with start, right? Which is our start node. Which is always start, right? It's always start, yeah, always start. So then we go, okay, what's connected to start? And that's A and B. So then we append A and B to this. And then we go to A. And then we see start, okay. We'll grab start, C, B, and end. And then we need to keep track of... No, I think it's best to just keep every single track separately. Yeah. So we just replace starts with starts, comma A. Yeah, this is way better. Let's not complicate this more than I need to. Start, comma B. And then we just replace it all the time with whatever this is. And if we do depth first or breadth first, that's fine. Because what we can do is we can keep a finished... In every traverse, we finish a path. And then we have, so we have like paths and finished paths. Something like that, maybe? Because what we can do is we can separate these out. So once we get, start A, and then we go to A, and A connects to end. So then we add start A end to our finished paths list, and then we're left with start, comma A, comma C, comma B, and then we have the remaining one left. Yeah, I think this is a good way. And then all we need to do is check if it's a member or not, what we're already doing if it's lowercase. And I think we can do that by checking... I don't think it liked this. I don't think it liked this at all. How do I check this properly? Probably just do this, right? Yeah. Probably do this, though. Wait. Oh. Yeah, it needs to be above Z. Because it's the other way around. You first get the capitals and then you get lowercase. And because Z... But they're gonna be two-lettered here, right? I think we'll be fine, because in principle... Yeah, it checks the first characters. So that's good to know. Okay, so let's do that. So we start with, always with start in the end here. What do you complete? Oh, yeah, because it's undefined. Okay, so what we then do is we do it like this. Traverse as well as the rest. I'm sure there's going to be some kind of infinite loop we're going to run ourselves into, but we'll see. So we grab connections, which will be... Oh, fuck no, we need to get the last element again. No! Why this again? Oh, fuck me. Did we do that here? Oh man, why? I hate this so much. It's fucking an ON get last elements. This is atrocious. If I find a better method, I will. Alright, so do last util last of our traverse. So this is the last element. And then it won't get all the connections that are. It'll be maps get map, comma, util last. That's the other way around, actually. Yeah, and then we just append it on, basically. So, no, we'll do like new paths equals, traverse plus plus connection or connection connections when not lists member. Let's do so connection needs to be lowercase, so it's less than no, it's above Z, right? It's for lowercase. And also connection not lists member connection of traverse. So these we get all our new paths. And then what I can do is if it ends with and then I can do this. There is no way to like split up a list based on elements within it, so we're gonna have to do two things here. Nah, I can get finished. Oh boy. What do I do for the name of... Fuck it, no. I can do this efficiently, but I'm not going to. Our numbers are going to be too small for it to matter. I can, like, iterate over it once, but I'm not going to do that. I'm just going to do it once. So we're going to call it unfinished equals... because we're going to have to do this horrible check anyway. Oh, yes. Look at that. Sneaky. Yeah, fuck that. And then we'll have a finished... where it equals end. And then we can do traverse map, comma, rest plus plus unfinished and finished paths plus plus finished. And then we also have our final case. New path is unbound. I'll take a look at that in a second, because we now have traverse. We don't care about you, and you must be empty. Finished. Let me return all unfinished paths. Oh, typo. So what's going on here? A new path is unbound. But I bound you. What are you complaining about? New paths, a new path. What? Rebel new path is unbound. But don't I abuse some lists comprehension here in the exact same way? But this is a guard, which they use here for fun, which is using when using map. I can't use that here. I think it's the call here that breaks it. No, it's not. What do you mean new path is unbound? I don't use that here at all. Yeah, look here. Is list v. New path. Type. New path. New paths. Did I make a typo here? Variable. New path is unbound. No, I see my issue. I'm just stupid. Wait, no, I'm not. I thought I made a typo. Oh, is it because I capitalized you here? My god. Hey, this should in theory work. Oh, yeah. Oh, yeah. I need to actually compile this shit. Util last one. Oh yeah, see util. No function clause matching, list reverse start. Oh yeah, I need to... Oh, huh. Curious? Why does that get called right there? No function clause matching list reverse start in line 50. Wait, no, like 18, just here. Oh, yeah, because you're a list of lists. That's why. Here we go. In line 18. And here we get the issue. Fun fact, there's this scope function is not perfect because last when the list is only a single item will break. See if I can find a slightly better function for this then. Oh, but this worked, right? Why did I not just use that before then? Okay. Ah, yeah, you're an atom. You are not allowed to. You should not be an atom. Start, B, end. Well, that is certainly a valid path. What do I want? Give me traverse. Give me. I don't care. Give me rest. Why not? Finished paths. So let's do it actually splitting into 2 lines. Do you have a hint to do test 2? I was happy being able to track all the paths without having to look up an algorithm, but the runtime is too huge for part 2. I'm still busy with part 1. So unfortunately I can't really help you there. I wish I could, but I'm doing a new language as well, so I'm not gonna be particularly fast myself here. If I knew, if I was at part 2, I wouldn't mind helping you, but then I would be solving it myself. So that's kind of the hint there anyway. What do we have? So, oh look, this is not right. So we have connections, which is A and B. That's very correct. But why do we get a new paths? Do we get start B only? Ah. Fuck. Of course. Or. Go. Yeah, or equal to. There we go. That looks pretty correct to me. Looks pretty correct to me. Let's test all the test cases real quick. Failed one. Eh? It seems like it gives this as an output? What? But it says it failed one, skipped one, and 0 and passed 1. Line 9. No. Here, line 57, it's this one that fails. Hey there, Romby. That's okay. I'm just writing a fairly simplistic... a fairly... simplistic... mapper. Which gives us some issues. Strangely enough, it gives us the right input for you, but then for the other things it errors out. Did I incorrectly copy this? No, I did not. So, when I say test it, oh, that's a test to see if it's lowercase or uppercase here. Oh, yeah, it's the other way around. See, that's true. And if I do like lower, it's false. Basically, if it's true, it needs to be, if it's lowercase, it also needs to be not a member of what the pathway we're in. So this is like filters. No, it's an alphabetical comparison. It's not a like super duper long will still be smaller than Z in this case. Because it just checks the first character. It's also why there's like no mixed stuff in here, so that comparison like always kind of works. The curious thing is, what's going on here? Why is it not... So I can comment out this, and I'm pretty sure that it just works on the other ones. So now it passes, but this one doesn't. Did I get the 226? So now the interesting question is, why do you fail? So we can grab this and just do F else. And we can just test it ourselves. Here we go. No match of right hand side. In line 30. Oh yeah, we need to. Not sure if this is the newest version, so I'm just doing it to be sure. In line 18. No match of right hand side value. What? Am I doing some input errors? Oh! Oh, I see. Look, it solved. The code was fine. It just, I just made a typo there. That's how they get you, kids. That's how they get you. Alright, part 1 is done, I suspect. Yeah. Let's see. After viewing the available paths, you realize you might have to visit a single small cave twice. Specifically, big caves can be visited a number of times, small caves can be visited most twice, and remaining small caves can be visited most once. A single small cave? Oh, fuck. Is it like a single one? Wait a minute. So in any path, you can visit a small cave exactly once. Big caves can be visited any number of times. A single small cave can be visited the most once. Okay. I think I have an idea to solve this. Oh, let's slightly copy this over. Because we know that you're correct. So, basically what we're going to do is we're going to modify this code a little bit. Because what we want to do is we want to have basically we want to generate a single map and we tell it what it can be visited twice, and we just grab all the unique ones. So don't do anything weird with like, oh, have we checked this one already, whatever. No, we're gonna have a double visit. Right here at the end. We don't care about you. And we make a traverse 2 here as well. What are you complaining about? Traverse 2 and traverse 4. Shut up. So let's first test you just by doing A. I want to grab the original vowels we have somewhere here. It didn't save it. Wow. Only goes back so short. Yeah, don't worry about it. What are you complaining about? Yeah, because you're missing something. Double. And your traverse 2 as well. Okay, we first quickly grab the symbol output again. So if we do part 2 now of the vowels, we should get the same answer, just 10. Or it's okay, because I haven't compiled it again. See, day 12. Just get 10. So my idea is to do this, or else. This is horrible. Or else connection equals double visit. It's a special case. And also util count connection comma traverse is less than 2. Just to double check, util count. It's one of my own functions, using to make sure it also works. Because you will be a list of items. Oh, I made a count list for this, right? Yeah, count list. That's the one that I need. It'll run for days. Shut up. We'll see. What language were you working on? Because that might change quite a bit. Python? Yeah, Python. Erlang is compiled. It could, in theory, work. This is more of a implementation of principle rather than anything else. Starting with something that works but is slow is much better than, well, starting with something that doesn't work and is also slow. Um, so yeah, this should now give us. So what I could do now is do this: is to sets from lists and do this. This is horrendously janky. So nice for optimization. Optimized my solution after also after it was working from a couple seconds to down to 150 milliseconds. I have a feeling that there's a lot of optimization you can do, but I'm gonna try my trivial case first. Okay. What do you mean? Argument 1, not a list, in function length 1. Oh yeah. 63. 36. That's not correct. So why would that be? Keep making what mistake? Yeah, it's not a bad idea actually. And this can just be lists, because that's all it does. Oh no, I made a util print sets. No, it was day 8. Was it day 8? I thought there was a day where I had my print. Maybe I deleted it. That would be stupid. I'm pretty sure I chucked it in my util one. I've got print map, but I got that from Nix. Fine, print sets. No, because it is, it's a list of sets. I must have had something. Wait a minute. No, not day 9, day 8. Yeah, I know. Good unions. There we go, print sets. This is gonna be a lot of stuff. Oh yeah, I need to actually export it. Can do elements, element 1 set, yeah. Or just do head, right? Why is it unused? Oh yeah, because I also have the way you can print something at the start. No, it only works on this. Okay, yeah. Okay. Yes, Nitro. What does the function say? It says print sets, not that other thing, you idiot. So what's going on here? Actually, why don't you also print set of the unions here? Oh, what the hell? Okay, what's going on? Didn't I say union at the start here somewhere? Oh well. What's my approach to the problem? Okay, so we have our list of connections here. First, what I do is I make a graph out of them, where I produce basically a map where every key is a node, and and then the value is a list of all the nodes it connects to. So we transform our list of edges into a list of nodes and connections, and edges technically, I guess. And what we then do, you're familiar with graphs, yes, somewhat. We then traverse. We give it a start place. We just start. And what we do is we get all the connections that are possible. And then what I do is is it too late to... Oh, fuck, is there an airline graph for this? Oh my god. I mean, I prefer doing it myself, but I'll check that later. Anyway, then we pick one of the unfinished paths, right? We have a unfinished and finished list here. How the fuck did you circumvent this? I blocked question mark by. I'll take a double check my banned words list later. So we add on every possible connection if it fulfills the requirements. So I double check the list, and there never is a connection of a big cave, which is uppercase. Oh, do you know the problem for today? I assume so. So basically, big caves never connect to other big caves, so we never need to check if we're going back. Okay, part 1 was find all ways to traverse a graph, but you have big caves and small caves, and you can visit these any number of times, so they're uppercase, and the lowercase ones you can only visit once for part 1. So if it's lowercase, we then also check if it's not already in there, or if it's uppercase, otherwise it'll fail. So we get all the valid ones, and start and end are lowercase, so they'll be fine. And then we check if the final one we added was end or not, and this is a bit janky. So we get our unfinished and our unfinished ones, and we append those back on. And this correctly gets all the paths possible. Part 2 allows you to visit a single small cave twice. So what I did there is modify this code so you mark it what small cave you can visit for the second time. And then we add on this extra check where you can also be... Oh, hey, this, so besides being lowercase, besides being uppercase, you can also be the same as the one you can visit twice, and because you can only visit it twice in total, it can only have been in the list once or 0 times before. Because if it already has been visited twice, oh, but start and end are included. Ah, I see. That's why we get like twice the number or so. Because that's a pain and we technically don't need to, I think. Yeah, we get the right answer, 36. (103) 3509 3509. Can you? Oh no, wait, you can. But I wanted it to be slightly more complex. I think you can do. No, wait. I think you're right. No, you're correct. I just remembered that you can use semi. Wait, can you use semicolons in there? Oh, give that back to me, please. Because I know here you can do commas. Yeah, it's commas and semicolons is an or, and colons. Commas are an else. I think this we can do with a semicolon, but no. See, that syntax isn't correct. So I'm not entirely sure. Regardless, this should work. AoC test 12. 2 tests passed. Oh yeah, it's horrendously long, but that was because I was just doing janky shit. Alright, this is gonna take a while, I think. Because the issue now is that there are paths that will just never visit the caves. So you're doing a lot of double checking. The reason for that is that you should be able to split apart whenever you... The thing is that what you can do is you can check if your path has no other cave system already in there twice. And if there is no other, then add it back on. I think that would work. Because then you, in theory, will still... Okay, hey, we got our answer, though. It's the power of compilation! Woo! Very happy about that, actually. What's our delta? I'm very curious about that. For 12. Very slow. Yeah. Guessing others had solutions where it was easier to modify. I already have seen... I haven't seen Stimar's code. Show me, what do you do exactly? Very nice. 29 lines, I'm impressed. This is just part 2 though. Oh, you can async it? Okay, wait a minute. Wait. Path calls. RPC async call. So wait. I'm extremely unfamiliar with the syntax here. So this is a function call, right? So that would just be this, right? But that would just be this call, I assume. First argument is always node. Oh, method function arguments. I see. So, wait. M is a module? I'm a bit confused about the exact syntax you have here. So this would be day 12, comma traverse 2, comma map, comma small cave. And then this syntax is all the same. No var args here. Okay. I am unsure what you mean. Oh, you have to use the args in a list. Oh, I see. Like that. You should have been more clear, my friend. I'm blaming you here. It can't possibly be me. And then just this. Bad RPC. Thank you for not calling that earlier, but you're welcome, my friend. Oh, wait a minute. This like exit undef. Oh, I need to export it. I don't think this is actually all that much faster. Time to check Task Manager. Well, it's doing something, but not a whole lot. There we go. I'm pretty sure that was I'm pretty sure that was slower than before. That's strange, though. Dude, this should be very easily parallelizable. I think your voice was choppy at the start. Let's run it again. Doesn't seem to be going that much faster, but maybe you're right. Maybe Union does take a while. But we can't. We can't get about the Union call this way, so I'm gonna implement my other idea. Where, yeah, Union is, we can't get around it, but we can implement my other idea, which is like, can visit twice. So basically we get a map, or we get a path, and we also get a small cave. And what we want to do is we want to get every single one of the small caves. In the list. Yeah. And we already had a... So we're gonna be nuking most of this anyway, so let me just grab this. So present small is going to not be you, it's going to be path. So basically we grab every single thing we visited, and we grab if it's small and not if it's start or end, because we don't care about those. And then we want to get like counts. So I can actually do that by doing this. So let's do util count lists small cave in path. So what we can do now is wasn't there an any? Because what I kind of want to do is I want to do... Because we don't actually care about the real amount. We care if it's below 2. Or no, wait. Because what I want to do is I want to first say if you're in there... Okay, no. So, okay. I can just make this a little bit more generic. Just make it can visit small. Because I can have just a little thing that says like max visits. And then I can have it generalized for both. Because kind of what we do here is we... so let's do like if max visits equals 1. Then we can get this case. Are you falling asleep? But I've got a better idea. Just can't visit cave. Let's make it cave. Because what I can do then is do Ha! You're right. You're very correct, actually. Very correct. Because for Z's, it doesn't matter. For 1, we return... if you're not already in there. And then we can actually work on logic. So now I can replace this entire call with just can visit. Okay, I should commit mostly or I need to get this out there just in case I fuck something up, because I'm going to start changing pretty significant sections here. Because this we can all replace with can visit cave, which is a connection. It's complaining because it's not finished yet. Can you explain me why the path start B, AC, AC, B is not a possible... Because you're visiting B twice. You're only allowed to visit a single cave twice. Here, let me show you the line where it says that. A single small cave can at most be visited twice. And that's why it's a fairly complex logic thing. Yeah, that's... If you don't have that, it'll run infinitely. Well, okay, it won't, but it'll take very long to do. So... And I can even not have to add the code if I can do can visit cave of a path, comma, cave, comma, nothing equals... comma 1. It's complaining because it's still not finished. Don't worry about it. Yeah, that doesn't surprise me that you'd have millions of paths then. So we get all the small caves that are present. This will be a performance hit, but it'll be saved by not having to redo this whole thing like a billion freaking times. And we're going to remove you because you're basically going to get replaced by a call to you. Just with 2 as a max visit now. So we'll do comma 1. Yeah. Because we can simply pass it on to you. And we just don't use this line because we won't ever need it. I need to keep this logic here though. Can't fizz, yeah, it's okay. And then you'll be comma 1 and you'll be comma 2. So we get all of the present small caves. If all below 2 equals to, is there like an Erlang? There wasn't Erlang any, right? Or an Erlang all? Erlang any? Yeah, so is it like a lists element? Yeah, any and all equals any. We don't care about the cave. Self. Visits equals below 2. So if not, this is I call it any. So if none of them are below 2, any. If none of them are below 2, sorry, any below 2 equals, if that's true. No, so this will be all below 2. Yeah, so sorry, this is all below 2. If they're all below 2, so this needs to be all. But I guess I can make it not any above 2. Just fairly simple. Yeah, actually that's it, right? Let's make this a little bit more explicit, just so we know what we're dealing with. Okay, now we can see the actual errors. So the logic here is that if you're Z, you're always allowed to visit twice. If shut up. If so, when we count all of the, we get the small caves that have already been visited. Yeah, I need to actually. We're not done yet, so if we get all the small caves that have been visited, and we count how many times they have been visited. Function any 2 on the what? Oh, it's lists. Oh yeah, because it's. Oh yeah. Traverse. And then you need to, of course, be max visits. And syntax error before. Oh, yeah, missing an extra space here. And that's because you need to be full stop. And you're just never used, which is fine, because we won't use you. Cave is unused. Yeah, that'll come in a second. Because you should be max visits. Also, you are now being typoed because you should be this. Path is unused. Yeah, because we don't care about either of these. Okay, so now cave is unused. Yeah. So if all below is false, so if there is one at 2, Oh, this is horrible to read. Yeah, fucking, I'm switching this back. So if all of them are below 2, if it's true, it doesn't matter. You can always add it on. But if it's false, you can only be added on. Or actually, let's do it like this. This is way better. You can only be added on if a match sim would be way better. I'll change it in a second. Just give me a second. If you're not present at all, so if count equals, yeah, here we go. Here, present equals list member. Is it in here? If present false, and we go for true, pointing to false. Oh, I love it. Comma. Isn't that amazing? So they're both false. Wait, no, fuck. If present is true, otherwise true is true. There we go, my bad. So how would I improve this a bit? All below limits. Because if they're all below the limit, if all of them are 1, you're always allowed to visit a small cave. And the thing is that, in theory, every single path will properly do it. Yeah. Maybe see, but no, it won't, because there's a syntax error. Slightly cleaner. Why is it syntax erroring? Oh, because there needs to be not anything after you. Yeah, the comma. Yeah. Okay, let's. Is val still defined? Yeah. Something's not going right here. Yeah, this is very much not correct. We're infinite looping. Why? Wait, yeah, I know why. You know why? This is wrong. Okay, maybe not go with that immediately, you idiot. $10. Last for fucking ever. Okay, curious. So I think we get So I think we actually can get part 1. Part 1 is fine, just the part 2 logic is not correct. Oh, yes. I think I have an edge case that I'm not covering. Because you will be start as well, but you'll never be part of path. So we can remove these. No, we need to remove the counts. No, could we do... No, I think we're infinite looping back to start all the time now. Because it checks start, and start is false. Yeah, so we can do that as well. It starts. $36. Yeah, I think we got it. Hey, that's a lot faster. I think. Actually, I don't know. Okay, it's still slow as balls. Oh, but why? Why is it so slow now? Because we're still traversing unique paths. I mean, it's still like a million of them, so it's fair enough. I feel like we're not properly removing... Is it even slower? I feel like we're discarding too many paths. Yeah, we're creating a ton and we're discarding a ton. Yeah. This is cleaner but slower. Oh, it's a lot slower, I think. Oh boy. Anyway, let's take a look at the leaderboard. Did I become 4th? No, I was 6th, because in the meantime Stimmer and Dennis solved it. Time to Google airline graph. Oh, but I could just return not present, right? Hey, forgot about that. Yeah, I think I mean this is not really an improvement in execution time though. How? Do all below limit Um... Like this? Oh my god, you're so slow. Okay. Digraph. Hey, but this is nice. But the issue comes from so get path. Yeah, the first found path is returned. Would this even work though? Because these are all adding, deleting, edges, whatever. Gets cycles, tries to find a cycle. Gets short path, tries to find the shortest path. Like digraph utils, maybe? I don't think we can use this next. Doesn't look like it's possible. No, I mean... Same, but the fact that we cannot get all paths is already damning enough. Yeah, like, you would have to limit vertices in some way, but the only way you can do that seems to be to delete one and then add it back in. Because you can delete a vertex. Or so you can delete an edge. All paths and utils. Components. Condensation, cyclic strong. Whatever the fuck strongly connected components might mean. Post-order, pre-order, reachable. There is a path, yeah, but that's just... Path. Yeah, I have to admit it doesn't seem that way though, Nix. Which is a bit unfortunate, I have to say. Yeah, subgraph? I mean, this would be great if you just needed to do, very simple pathfinding, but no, that won't work. That's unfortunate. Yeah. It is what it is. But yeah, slow as always, but yeah, didn't climb. We're still behind Marvin, who didn't even do today yet. Poor. But yeah, Delta's pretty low. I'm guessing their structure was already good enough, but mine totally wasn't. I like this better, but I mean, I have a feeling. Just do some quick reporting. P N. Maybe. What are you complaining about? Oh, whoops. I mean, I have a faster version, Crazy Wolf. It's just that it's not as clean. Oh, yeah. Okay, it goes too fast, but the numbers need to be going down. You see this? The length of arrest? That's all the paths we still need to check. And it's only going up. So when that starts going down, we're heading the right way. We also know that finished paths is supposed to be like 1,000,000 or so. Wait, what was the actual answer? Oh, it's only 130,000. But I think we're only at 30,000. That's strange. So how are we generating so many invalid paths? That's what's confusing me. Wait a minute. No, that's correct. True. See, it is going down. So it seems that at first we're just generating a fuck ton of graphs. But this takes like tens of seconds to run, whereas our previous solution was much, much faster. Which what that did, but I think it's really this. Time to build a nice graph, yeah. I think it's this. So what we do in the other one, we just tell it already which cave you can visit twice. I'm surprised that speeds it up so much, because this list is super slow because we have to count the list every single time. And I think that there's probably a way to reverse that, because I'm pretty sure that is the very, very, very slow part. And I think you can maybe make a recursive version that's a lot faster. I'm surprised that it's so much slower, though. Hey there, hamster. We're already done. I already built a super fast, dirty solution. Now we're working on a super shitty, super slow solution that takes like a minute to run. I thought it was smarter, but no, it's much dumber. Does countless small cave path happen more than once, or is it unique? It happens for every single new connection we find. So it gets called once for every element. What do you mean exactly? The combination of arguments? Oh no, but like you iterate over small caves. No, because the path is unique for whatever you're traversing at the moment. Because path would be like here. And I do need to count because I need to know if it's occurred twice. But the thing is, for that, what I can do, maybe I should flip around these checks a bit. The thing is, before we already knew if you were allowed in, because we could check if you're allowed in, just check if you're present, and if you're present only once, that's okay. But if you're not allowed to be present once and you're in there, then you're done. But I guess in theory you could optimize this a bit. Maybe a short-circuiting recursive count list. Yeah. Because there we go. 131254. 131255. It's a correct answer. It just takes for fucking ever. Yeah, exactly, right. That's what I was thinking as well. No, I built a much faster solution, hamster. Yeah. Because I didn't like it. I had this code duplicated for each version. So, still third on Delta. I'll take it. Yeah, but I was probably pretty shitty in that regard. Because I had to retool a decent amount of my code. And else it's Erlang, so, you know. So that's not bad. Yeah, well done. I need an accumulator. Oh, but no, you can just do that in limits. So, and then you can do LM. No, wait. Whoopsie. No. Do it here. And then if it's the same, then just continue with list and limits. And do... So how do I check for... Oh, we don't care. We just care if, like, if you're empty and you're a value... Head mismatch. Why? It's basically... you're an empty list. The typo? Oh, yeah, whoopsie. You're right. There we go. So how do we use this correctly? Just replace you and make if it's true, right? Let's commit slow AF code. So we should replace this. Which is small. Where add another shortcut. Max visits. Ah, wait a minute. Fuck. The Formula 1 race is going to start in a second. Let's see, I need to... Because I'm correct, that started like in like 5 minutes, and I do want to watch that. But I'm pretty sure that there must be a way to do this faster. Like, there's no way. Okay, let's look at band there. I'll work on this until it actually starts, and then I'll call it. Pretty similar to mine, to increase the speed by placing the map for checking which spot I had on the. Increase the speed by replacing the map for checking which spot I was on by string comma string list, because copying hash map. I don't copy any hash maps here. These are all lists. The hash map is this thing, map. Oh, for hamster. Okay, okay. Increase more than 3 is undefined. Because I typoed it. Oh, because I typoed everything. Shut up, hamster. But this is the other way around, so it's like not this. So it not occurs more than that, and then if they're all below limits, we just basically check. Do we care about the small cave value? No, we do not. So we can just do present small. An error, yeah. House is on, oh fuck. All one. Oh. Is there really no way to do like all on a single value? Are you kidding me? No, let's flip this around a bit. So this is if it occurs more than, yeah. This needs to be +1. So it occurs more than is not correct because it needs to be it's like +1. So 2 will subtract 1, and then it needs to find another one before it'll be finished. So that's good, but it doesn't correctly occurs at least would be better. So basically we check if any of them occurred at least. And now I need to like reduce this. Which is like, I'll write my fucking own any. What do you mean next? Because, like, what exact shortcut are you talking about? Because there's quite a few possible ones that I could take. Oh yeah, I need to compile it. Except doing the double visited inside the any, and then doing the list member at the end. Wait, except doing the double visit inside the any and doing the list. So like this? And for this, I think we can actually pass it along something already. Just create a list of all small caves and just pass it along. Because even if it's not present, it doesn't matter. Okay, let's test this and see if it's faster. Error. Did I miss an IO format? Oh, I didn't save. And we got the wrong values now. No, this is like our own. I think I'm just missing a little bit of code here. So what if I do, let's compile it first. 1036. So you were still correct. You changed the function name for at least, but didn't change the logic. No, that's still. I wrote the logic for the old one because what it does, it checks for at least 2 by if it finds an element, it just subtracts 1. So if you have 2 and you find the first one, it subtracts 1, goes to 1. And then if you find the second one, it subtracts and it goes to 0 and returns true. And if you have only 1, it'll say it 1, and it'll just reach the end empty list to return false. And if you have 3, it doesn't matter, because I already found 2. And it pops off the element of the list. So the only issue that you could probably do this on every single one. I mean, we can do this, right? So it gives the wrong value on the second input. Anyway, I'm gonna go. Ugh. We solved it somewhat. We just haven't been able to fix the broken shit. Did I? Oh no, I reversed it. I reversed my logic, I think. Did I? I don't remember, man. No, because curse at least tells me if it's true if it revisited at least twice. So none of them have to be yeah, not. So it has to be not any. And No, it needs to be an or else, because if this is... If none of them have been found to be true, I think all is actually faster here. Just rewrite this all. Because the logic here is very simple. If it's false, no, it's false. Otherwise, it's true. You know what? I'm just confusing myself here. I am gonna go. The weirdest part is that it fills in different pits. Doesn't matter. Cheers for watching. I'll be back tonight with Patreon, maybe or something else. I don't know. Everyone, go enjoy the rest of your Sunday, and I'll see you later.